Welcome to this physics tutorial. We're going to talk today about finding displacement. Now, before we even start, displacement is the straight line distance between the initial and the final point. So it's always helpful, I think, to draw out some sort of picture or sketch to help you visualize that straight line distance. So go ahead and read this problem. It says Susie drives 16 miles north, then turns and drives 12 miles west. What is her displacement? So like we said, let's draw out a picture. So if she starts down here, she drives 16 miles north. So let's label that as 16 miles. And then she turns and drives 12 miles to the west. So that's her 12-mile distance. Now, if we were asked to find her distance, we would simply add 16 plus 12. And that's what the odometer would read on our car. However, we are asked to find displacement, which, like we said, is the straight line distance. So we need to go from her initial point all the way to her final point, and that there will be her displacement. I'm going to label that as D. So what we need to do is find this length. This length will then be our displacement. So if you think back to trig, when you learned about Pythagorean theorem, we know there's an equation a squared plus b squared equals c squared. And that applies to right triangles, which if this is 90 degrees, this is in fact a right triangle. And I plug this in. I have 16 miles is one of my sides, 12 miles is the other side, and then the hypotenuse, or that longest side, is my displacement. So when I solve this, I take 16 squared plus 12 squared, I get 400, and that would be miles squared. Gives me d squared, and then I take the square root of both sides, and I end up with d equals 20 miles. So her displacement is only 20 miles, although her distance would be much farther than that. So when you're asked to find displacement, all you need to remember is that it's the straight line distance between her initial and her final point. Good luck!